The next test we're going to talk about is an Anova, and it is an extension of the t-test, so it's still looking for the difference in means between the two groups, but it has a little less rigorous assumptions. So it's actually looking for continuous across two groups, so it's not just looking at one group. Again, sort of like the paired t-test, but you can add lots more variables. So it's looking for what impact. We do it a lot for pre and post when we're looking at two groups who've gotten interventions or not. We are also looking for if there are other variables that impact them. So you're not just looking at did they get the intervention, you might look at other sort of control variables of their age, their gender, those kinds of things. So it's sort of like you're building a more robust thought process within your data analysis when you use an Anova about what implications could have for the independent variable. It could be a lot of dependent variables. With the t-test, that's a little bit harder to do, but with the Anova, you can look at like two groups of people, so they're not necessarily always independent, and you can look at a wider range of variables that might impact why a program or why an intervention or why a specific thing had an impact. So it's sort of adding more variables to the model, if you want to think about it that way, and it's also allowing you to do more looking at the same group of people over time, but still looking at that interaction impact from what we used to call control variables, alternative hypothesis, to see what's actually happening. And what usually happens is you find out that, yes, there is something going on, and then you have to go backwards, right? But you've sort of seen a list of variables that have impacted it within each of these groups. So it's adding a more robust model. It's allowing us to compare two groups. Again, that's sort of before and after without just doing a simple paired t-test, because a paired t-test still has a very limited amount of variables you can add to the model to look at. This gives us a bigger model, a more robust model. It's also, we have to make sure that we're really looking at the variance and other indicators there. You'll see other videos about this, but Anova is really, really popular for a lot of pre and post tests when we're looking at the same dependent sample, and we want to look at not just have they had the program intervention, but other things like their age and their education level and maybe where they get their health care, or have they been in other programs, or have they moved out of the program and come back, what kind of amount of what we call dosage have they had in the program. So a whole lot of variables could be added to an Anova model, which it really couldn't be in a paired t-test, and specifically in a specific t-test that would be more limited. This gives you a wider variation. You can have continuous variables, you can have nominal variables, you can have more than one, so it gives us a bigger, more robust model, which might tell us more information because, as we've talked about in research, usually the response and the answers is a little bit more complex, and this adds for another layer of complexity.